Welcome to the Nasscom Conversations. My name is Sangeeta Gupta, and I'll be the host here today. Nasscom Conversations is the platform where we are bringing together global thought leaders to explore the transformative impact of technology. In each episode, we'll dive into the latest advancements on what's happening in the world of AI, how is the innovation and digital landscape changing, and you really hear from experts on how are they shaping the future worldwide. I'm very excited today because we have Dr. Anandkumar joining us today. She's currently the Bren Professor of Computing and Mathematical Sciences at the California Institute of Technology. Dr. Anima, welcome to the podcast.
Thank you, Sangeeta, for having me.
So Dr. Anima, there is so much happening in the world of AI. While I know you would have been working in this field for a very, very long time, but I think post Chat GPT moment, I think the whole world is enamored with AI, both the positives, the negatives, the opportunities, the risks. How are you seeing the timeline we are in today, and how do you think about how and where is this shaping up as you see it as a researcher, as an academician, as an innovator? What would be your perspectives around where is AI moving?
Yeah, no, it's been such an exciting journey as somebody who's been working for more than 2 decades in AI and seeing it grow from science fiction to reality, right? It's just been so interesting to kind of like start from theoretical foundations because, back when I started my grad school, you could do maybe small scale simulations, you could work with small data sets, and neural networks were nowhere in the picture because, they needed big data sets and big compute. So, but starting there and having that right foundations, I think is still very valuable even in this day, just as I'm going to be teaching even today the course on foundations of machine learning. We kind of like chart through that journey, right? And of course, once deep learning became practical, and it turned out that the level of compute we had even a decade ago, along with data sets from the internet scale, collection, was possible to train practical deep learning. And to me, that's when the revolution just like jump started. And ChatGPT is really, to me, a culmination of what you could do, in my view, purely based on data from the internet, right? So, and even that, over the last 2 years, there's been a lot of private data that is assembled, that is much more curated. So we're kind of like starting to see the limits of data availability, and that's where there is the debate of what comes next. And to me, I think even as we're seeing this revolution in terms of internet scale data with deep learning, at the same time, especially over the last few years, I've been working on the intersection of AI and scientific domains. And, once I joined Caltech, to me, it was always this place I associated with Richard Feynman, with all the Nobel Prize winners in various areas of sciences. So, what can AI do for these various areas? And not just that, to really tackle the foundations of scientific method itself. Can AI be deeply integrated into sciences? And that's where the last few years I've really focused on now, showing not only that AI can do as well as current methods, but surpass them in a really grand way, right? Being able to have simulations that are much faster, being able to have forecasts and predictions that are much better in a number of areas, being able to design better devices, drugs. All of these are, to me, we are still at the infancy. It may appear with ChatGPT, we've solved all the problems in AI. We already have practical working products. But when it comes to scientific domains, we are still early in the journey, and that's what excites me of things to come.
No, I think that's fascinating, Anima. And, maybe just to build on the scientific discoveries and AI and scientific discoveries, can you help us just paint a picture of how you see the world changing with AI's integration with scientific discoveries? Maybe a couple of use cases that you think are visible on the horizon in the next few years.
Yeah, I mean, we already have many cases that are working in the real world. So more than 3 years ago, we built the first AI-based high-resolution weather model that is not only accurate, in fact, even more accurate than the existing weather models in many situations. And not only that, it's tens of thousands of times faster. So what would take a big supercomputer that to run current weather models, the traditional weather models, takes a single desktop gaming GPU that you may have at home, and we've open sourced the model. A number of weather agencies are using this, as well as researchers are building on top of this. So it democratizes weather modeling and not only that, when we think about extreme weather events, the unfortunate wildfires that happened close to Caltech here, as well as, we think of hurricane storms. So worldwide, we are seeing increase in these extreme weather events with the climate change. And so this ability to not only have early forecasts of extreme weather events, but also the risk assessment, right? The challenge that comes to events like these are it's chaotic. So you know, cannot possibly, even with all the compute, all the data, it's still impossible to accurately predict what's going to happen. What we saw with the wildfires here in Pasadena was unprecedented winds, right? So these are rare events, but of course, when they happen, the damage from them is also very outsized. So we can come up with a much better probabilistic forecasts or risk assessments using AI-based weather models. And that's because they're so much faster. As I mentioned, they're tens of thousands of times faster. So you can afford to now do much larger statistical ensembles, meaning you look at all different scenarios, you perturb the current conditions, like say wind conditions, and check, how does the path of the hurricane change if I add certain amounts of noise to the current conditions. And so the more scenarios you can generate like that, the better you have in terms of risk assessment, because you can now count how many of those paths, say, make a landfall and can cause damage. And so those kinds of risk assessments are critical, in terms of assessing when to evacuate a certain zone, for instance, having valuable time to save human lives, maybe save property. So those aspects are, I think, will become even more important. So we've done these kinds of ensembles with weather models that are now much better what you can do with traditional models. So this is not just AI being faster. This is enabling now us to deal with extreme weather events that wasn't possible before. So that's one example, but more broadly, the kind of techniques that have made these AI-based weather models possible are the aspect that you can have AI not only learn at one fixed resolution, or, if you think of like the uh, information across the globe, you can think of them as pixels. And if you fix the number of pixels and learn an AI model, it only works at that resolution. And that's how, if you look at image generation tools, whether it's ChatGPT or any of the popular ones, that's how they work. They work using a fixed number of pixels. But that's not how the natural world is, right? So even if we represent the weather model with a fixed number of pixels, the reality is it's a continuous process. And the reality is, if you zoom in, there's all kinds of local features and topography. There is clouds that have fine scale, and that's what is very important to model hurricanes, for instance. And so we are able to do that using an AI technique called neural operator. And what it's able to do is to be able to learn the mapping from continuous function to another continuous function in the output, which means it's not limited to one fixed resolution. So it can now capture information at multiple different scales. So if you zoom into a hurricane, it can still capture those fine scale details, whereas other standard computer vision models, other AI models are not able to do so. And this kind of aspect is really critical in many other settings. For instance, we designed the ability to stabilize drones under extremely turbulent conditions. We've designed a medical catheter that reduces bacterial contamination by 100-fold. We have come up with AI that can predict how plasma evolves in a nuclear fusion reactor. And even here, plasma can become extremely unstable, right? And you need fine scale modeling because you need to really zoom in and look at a fine grid and how plasma evolves. And that's what makes traditional methods very expensive. And we are able to do this kind of prediction more than 1 million times faster than what's possible with traditional methods. And because of that, we can now run these models faster than real time. So we can use this to control fusion, and hopefully one day we would be able to avoid disruptions while having sustainable fusion. So AI is game changing in its ability to model these kind of complex processes.
Very, very, very interesting, and especially the fires example is just so live as we are living it. I just want to, while we're talking about obviously the potential that AI is offering, uh, there's also that equal concern on accuracy and reliability, and especially when you go into these very sensitive situations. How do you ensure that those accuracy and reliability, and I know there's a lot of testing validation that happens, but at the same time, and particularly I think in some of the more consumer use cases, we are hearing a lot of concern on safety, reliability, and hence the risk of regulation. How do you perceive that environment, right?
Mhm. I mean, as someone who's been working in AI for science, this is inherent to the problems at hand, right? So if, like the weather example I mentioned, you need to stress test it and ensure it works under all kinds of conditions. And when we started working on this, a lot of people were skeptical. Weather modeling has been done for decades. AI can't just one day come, and we as outsiders can't just come and be able to just upend the field. And the thing is, you expect, because there are hurricanes are rare events, it wouldn't be able to model that well, right? But what we've seen over the last few years is these models are able to capture those kind of physical signatures because they are very clearly differentiated from other kinds of events. And so you may not need as many samples, which is great. But then in order to add robustness, can we add different kinds of laws of physics into them? So that way conservation laws, for instance. So you have more confidence that it is doing something physical, its outputs are physically valid. And we've done that in many other scenarios as well, where you need, like, the guardrails of physics ensures that the model, even when it makes mistakes, is not going to do something that is not going to happen in nature. So I think that comes more naturally in these applications for sciences, as well as robustness is inherently needed. If you think about, for instance, we designed a medical catheter and we simulated fluid dynamics, and we wanted to prevent bacteria from swimming upstream along the walls of the pipe into the human body and cause infection. And to avoid that, we wanted to design these triangular grooves that create turbulences or vortices that would make it hard for bacteria to swim across, and hence you prevent the bacteria from swimming into the body. So this is all nice in theory, right? Of course, the question is, once you design this in simulation, what happens when you go and test it in the lab? Is you always need physical testing. You need it to work in the real world. And that's another kind of robustness check. And to our surprise, our model just worked for the first time, and it led to 100-fold reduction in bacterial contamination. So in other cases, if it didn't, you could go back and forth. And so in many of these scientific applications, these requirements of robustness, safety, I talked about how we looked at stabilizing the wing of drones and airplanes under extremely turbulent conditions, and what is the right reinforcement learning methods to do for that. And again, right, so this we did it in a wind tunnel under very turbulent winds. So, so you need these like robustness, stability, and safety uh, kind of like modeling that needs to go into this to work. So I feel much better here because the guardrails of the physical world naturally require these kind of robustness, so you can very quickly check and ensure that you're designing methods that conform to those requirements.
Oh, no, fully agree with that, Anima. But from a broader AI world, do you worry about the risks of AI? I mean, we've seen those camps of the doomsday scenarios and the ones who are believing in the opportunity at the end of the tunnel. But are there real risks that you worry about? Not so much in the work you are doing, but the broader AI ecosystem.
So to me, AI has always been an open source revolution. And when I started working in the field, and as deep learning started taking off, it was really right open data sets like ImageNet and competitions, and people publish, they open source the code, and that's what led to this revolution, right? So ChatGPT didn't just happen in a vacuum; it was built on top of all the open source work, including some of the open source language models that when I was at NVIDIA, right? NVIDIA released this code, and OpenAI and others kind of further developed on that. So the important thing is to not lose track of that, right? And the worry is, especially some of the recent attempts at regulation, uh, hit at the heart of open sourcing and really make that untenable in some cases. And I think that's the difficulty. It's very hard to get regulation right that does not stop innovation, that does not come in the way of open sourcing, because there is all kinds of really I feel like bad analogies made with nuclear weapons and what so. I mean, AI is so different, right? It's not just one specific technology. It's not one specific tool. It just, like the kinds of scientific problems that I told you about are so broad. It's all of science. And so we cannot have this like one rule fits all, or we cannot just say, oh, if the model is large enough, it's probably dangerous, so we should regulate it. Every day we talk about innovations where there is more efficient techniques to train these models, the sizes of these models is coming down. And at the same time, maybe you do more interesting things with larger models or more beneficial applications. So it's, and that's kind of like where my worry has been over the last few years. It's more to do with the regulators getting it very wrong, and uh, you know, uh, and harming innovation, and especially also innovation across the world. How do we ensure democratization, that AI reaches everyone and solves local problems, that local population can work on AI in meaningful ways?
I think AI has become this geopolitical tool now where I think every country wants to build its own sovereignty around it. And I think it's fascinating to see how technology has become such a tool for geopolitics. But I think that's the world we are living in. Anima, you mentioned about NVIDIA, and NVIDIA, I think, recently talked about physical AI. And I know while in your world, you've probably been doing it earlier, but I think suddenly that terminology of physical AI seemed to become much more real. How do you make that real for the common person to understand what do we mean by when we are saying physical AI, and what goes behind it?
Indeed, when Jensen Huang, NVIDIA CEO, talked about physical AI as the next revolution at CES, this was like something that I work closely at NVIDIA and also, right, so something I know Jensen is personally very excited about, because when uh, my team as a effort developed this first AI-based weather model, Jensen got very excited, and that's how he created the NVIDIA Earth 2 effort. And there is a lot of innovation that spurs from like kind of like just going and trying out, right? And with the physical AI, it's a very broad term. So it can mean weather models, it can mean robotics, it can mean the ability to do engineering design. And now the question is, what is the chat GPT for physical AI? I mean, I don't think it'll be first of all, a chat interface, so that's a misnomer. But to me, what is
But
really
the chat
clear?
GPT moment, right? Yeah.
Yes. And also, what does it mean to have universal physical understanding for AI? So, can AI understand different forms of physical models, be able to simulate, design, control? So, all of these aspects that you expect, currently there, it's either done through other kinds of numerical simulation or it's done in actual physical experiments. Can AI create physically valid digital twins? So not only digital twins that look good, there's a lot of visualizations, right? That may just like is about focused on things looking good, but instead is able to inherently understand the underlying physics of it. So it's able to do these simulations much, much faster. Like I mentioned, the example of nuclear fusion, where we are more than 1 million times faster. So it's able to do that while being also robust and accurate. And so that ability, it will be game changing in just such a broad range of domains.
So when we think of a country like India, Anima, where we are more right now at the application layer in AI, yes, we are building a few local language models, etc. But I think most of the innovation that's happening in India is in the space of applications. And then when you think of, revolutions like physical AI coming to being, what do you think countries like India, and how can we approach uh, much more strategically some of these big changes that are happening, so that you're not just a use case capital for the world, but you're doing much more, especially in sectors like you said, right? Whether it's healthcare, whether it's manufacturing in India, there is just so many different use cases of scientific discovery, healthcare. I think you can just think about just every use case, every possible solution that you can do at scale here. Any thoughts around, what can be India's play in these areas?
Yeah, absolutely. I mean, to me, as somebody, who grew up in India and having, my parents both be engineers and running a factory that brought some of the first computerized manufacturing to my hometown in Mysore, I really think, manufacturing is the lifeblood of the country, right? And how do you leapfrog to the latest technologies in manufacturing and use AI embedded in that to further have gains and further have differentiation that really increases efficiency. And to me, like you mentioned, oh, AI is now a lot in the application aspect that India is kind of like building on. I think you need to think about going all the way down, right? So semiconductor space where Taiwan, Korea, there's a lot of leadership there, right? That is just like something that everybody is dependent in. The NVIDIA is dependent in having chips manufactured with TSMC, for instance. So that takes, right, a lot of focused effort to build that kind of expertise. And and I know in India, the efforts are getting started to have that leadership in semiconductors. I've talked to many leaders, business leaders in this space, and I think you should always start there. You should start at the source because, we'll see a revolution in semiconductors. There's a lot of physical limits that will become challenging as we go to, right? Like more miniaturized processes, but also the thermal will become a big challenge. You're packing more of these things, it gets harder, right? It's simple. But how do you overcome that? And how do you do better designs? And how do you manufacture with very high requirements of reliability? This is non-trivial, but I think India can really bring in all of the engineering expertise, the ability to have like workforces that are very focused and disciplined to tackle these kind of challenging problems. So I would keep a lot of focus there. While of course the other aspect is in terms of like the right software, the ability to train models, build data centers. I know there have been efforts to also scale up many of the data centers and modernize them, right? So again, the aspect of being able to have models for local languages, right? So that's a big one that a lot of I know focus has been, and the question is from there, how do you have meaningful applications that reaches all the population, right? So because India is so diverse and has so many languages, so many dialects, how do you go from just training on a few languages? Can you like capture the diversity of the country, and can you really capture the cultural richness, right, to then create meaningful applications? I know many entrepreneurs are looking into this, and this is an exciting time for sure.
I think definitely. And in India, given our diversity, I think speech to speech is becoming quite interesting, right? Because not everybody will be able to type, and those limitations may also exist. I know we're going to run out of time, so just a couple of last questions, Anima. One is this whole debate around AGI and artificial superintelligence, and what will it do to humanity? Where are you on that one, right? Are you seeing this in the near term horizon, or it'll come and go, right? Or
So I think to me, the aspect that, oh, AGI can just be language based is flawed. There is no AGI without understanding the physical world, right? Because ultimately you want AI to serve the needs of humanity. And that means it has to understand the physical world, be able to reason, design, model. And if you see many of the logical flaws that ChatGPT or any of these chatbots have is because they miss what happens in the spatial world, right? Or they miss many of the kind of like that experience of the physical world. And so I think that's a big limitation currently in these models. The other one is, the definition of AGI itself is kind of all over the place. And I think a lot of people are amazed at the abilities of these chatbots, but we need to be careful to treat these the challenges as scientifically valid tasks, right? Because if you show these models training data that look very similar to test data, then it's not AGI, it's more like supervised learning. And in many of the recent problems that, like solving some of the math problems, there have been like lots of like heavy training that has happened on very similar problems. And so, yes, it may be able to solve it, but, AI is very different from how human intelligence, right? When mathematicians, they build all of those foundations and then try to make connections and new mathematical discoveries. But here, if you're asking AI to solve lots of synthetically generated problems that look somewhat similar. For instance, in case of Olympiad, there's like a very structured way to design these problems. And so that becomes a big challenge. How do you then evaluate this model is capable or not, right? And if you give it, researchers have done some very interesting things where in these math problems, they add something completely irrelevant, right? Like some rhyme or some poetry that has nothing to do with it, and then it gets completely confused. So, so there are like these simple common sense tests that, these models still fail. I mean, they're getting better as there's more training, more alignment. But if there are these fundamental flaws, to me, that's not AGI.
Yeah, no, I totally agree with that. So, just my last question, Anima, is really about you being an advocate for diversity in AI research, right? So what do you think should be key steps that organizations or academic institutions or tech companies should be following to ensure the data itself is not biased, but many other things that are coming in are truly inclusive by nature?
Yeah. I mean, to me, like the important thing to keep in mind is, asking for better diversity and inclusion is not against merit, right? It's very pro merit. And that's, I think, there is a lot of misunderstanding around that. So I want to clear that first, because, to me, the aspect is, when there are very clear standards of what is excellence, what deserves a promotion, then there is no room for bias or there's no room for, which is actually a flaw in the current system that affects everybody, right? So the more transparent you make the, requirements for, different positions or the ability to advance in an organization, you also build better trust in the workforce. You remove that like politics, and you remove the uncertainty around what people think their careers will be heading towards. And that's something, and that's not easy. I think that's the challenge, because a lot of organizations are more kind of like things expanding right in an unplanned manner, especially many of the tech organizations that experience sudden growth. And I think it's but being thoughtful and having leadership that really cares about its employees, I think that's important. And this really is, again, an opportunity to fix maybe gaps in the organization that may just be rewarding wrong kind of behavior that doesn't even benefit the growth of the organization. So that's how I see how we should think of diversity and inclusion.
I think it's a very debatable point at this stage, but I think the core fundamentals of it are still very, very important, right? It's about how it's getting implemented and it's not taken as a quota for doing certain things. So totally
Absolutely.
agree with you. So thank you so much, Anima. This has been a fascinating conversation. Truly appreciate the time you've taken to join us.